Hello viewers, in this video we'll see what is test of adequacy of index numbers, and under that we will see what is time reversal test. So first we will see what is test of adequacy of index numbers. If we see, there are many methods that are used to construct an index number. We have seen various methods to construct an index number, like we have seen relative index, then we have seen simple aggregative method, weighted aggregative method, Laspeyres, Paasche, Fisher's ideal method. All these methods are used to construct an index number. It is important to test whether the index number which is constructed, it is consistent or not. Now this is done using various tests. Under that we are going to see only what is called the time reversal test. So we will see what is time reversal test, and we'll solve some problems on this. According to this time reversal set, the method that we use to find the index number, it should give the same ratio between one point of time or another for comparison. Now let us take, let this P01 is the index number for current year 1 on the basis of base year 0, and let P10 be the index for year 0 based on year 1. Then if this index number, if it satisfies time reversal test, then P01 into P10, it should be equal to 1. So this condition has to be satisfied. If it is satisfied, then we can say the index number satisfies time reversal test. Now say for example, if we have the index for 2020 with 2003 as the base year. No need 2020, it is not a normal year, let us take 2018. If we have an index with for 2018 with 2003 as base year, then it is given by P01. And if we construct an index for 2003 with 2018 as the base year, then it is given by P10. Now this P01 into P10, this should be equal to 1. If this is equal to 1, if we find this index using any of the method, and if this condition is satisfied, then we say that method satisfies time reversal test. Now we will see some method whether it satisfies the time reversal test or not. If we consider Laspeyres method, then Laspeyres method, we have the index P01, it is given by summation P1 Q0 upon summation P0 Q0. This is P01 according to Laspeyres method. So it is the index number for the current year 1, which is based on the base period 0. Now if we want to write P10, then this is equal to, this is the base period for, this is the index for the period 0 with the current period as the base period. So this will be equal to summation P0 Q1 upon summation P1 Q1, because here we are taking the current year as the base year, so we have to take Q1 here. Now we can see that P01 into P10, this is equal to summation P1 Q0 upon summation P0 Q0 into summation P0 Q1 upon summation P1 Q1. This is not equal to 1. So Laspeyres method, it does not satisfy time reversal test. So if we substitute for any values, then we will not have the product of these two equal to 1. The product of these two is not equal to 1. So Laspeyres method does not satisfy time reversal test. Now coming to the next method, which is Paasche's method. Now we will see whether Paasche's method satisfies time reversal test or not. Now according to Paasche's method, the formula for the index for the current year using 0 as the base year, it is summation P1 Q1 upon summation P0 Q1. Now if we have P10, that is if we take the current year as the base year, and if we choose the base year as the current year, that is if we do the other way around, then P10, this is given by summation P0 Q0 upon summation P1 Q0. Now if we want to find P01 into P10, this is equal to summation P1 Q1 upon summation P0 Q1 into summation P0 Q0 upon summation P1 Q0. Now this is also not equal to 1. So Paasche's method also does not satisfy the time reversal test. Now coming to the next method, which is Fisher's ideal method. Now Fisher's ideal method, it is calculated as the geometric mean of Laspeyres index and Paasche's index. So for Fisher's ideal method, if we consider this P01, then it is equal to root of summation P1 Q0 upon summation P0 Q0, this is Laspeyres method, and into summation P1 Q1 upon summation P0 Q0. P0 Q1. This is Paasche's method. So Fisher's ideal method, P01 is calculated as the geometric mean of Laspeyre method and Paasche's method. So P01 is given by this expression. Now coming to P10. It is the other way around, that is we use the base year as the current year and the current year as the base year. So in that case, this is equal to root of summation P0 Q1 upon summation P1 Q1. This is using Laspeyres method into summation P0 Q0 upon summation P1 Q0. This is using Paasche's method. Now if we want to find P01 into P10, then it is equal to the product of these two. Now we know that root A into root B, it is equal to root of AB. So root of this expression into root of this expression, we can write it as under root of the product of these two expressions. So it is equal to root of summation P1 Q0 upon summation P0 Q0 into summation P1 Q1 upon summation P0 Q1 into summation P0 Q1 upon summation P1 Q1 into summation P0 Q0 upon summation P1 Q0. That is here P01 into P10, it is nothing but under root of the product of these expressions. So it is root of summation P1 Q0 by summation P0 Q0 into summation P1 Q1 by summation P0 Q1. This is what is written here. And then next we have the next expression P10. It is the product of these two. It is written here. So here we can see that these two will cancel, these two will cancel, then summation P1 Q naught Q naught will go, then summation P naught Q naught, summation P naught Q naught will go. This is equal to root 1, which is equal to 1, which means Fisher's ideal method satisfies the time reversal test. So if we see Laspeyres method and Paasche's method do not satisfy time reversal test, whereas Fisher's ideal method, it satisfies time reversal test. Now we will see the exercise question on time reversal test. Question number 9 from the exercise of student support material unit 6. Based on the given data, check whether Paasche's formula and Fisher's formula will satisfy the time reversal test. So to check whether Paasche's formula and Fisher's formula satisfy time reversal test, we need to we have to find first P01, that is we need to find the index number for the current year with 0 as the base year, and then into P10, and we have to find whether this is equal to 1 or not. If it is equal to 1, then we say the formula, it satisfies time reversal test. If it is not equal to 1, then we say the formula does not satisfy time reversal test. Now we'll do the problem. So let us draw a table like this. So we have the commodity P, Q and R. Now first we have the base price, then the price in the current year, then the quantity in the base year, then the quantity in the current year. Now the price in the base year we have 4, 6 and 8. So this is 4, 6 and 8. And then the price in the current year we have it here 6, 4 and 10. So we have 6, 4 and 10. And then we have the quantity in the base year, which is Q naught. It is 10, 15 and 5. So here let us write 10, 15 and 5. And then the quantity in the current year, it is 15, 20 and 4. So Q1 we have 15, 20 and 4. Now let us find each of these. First let us find P naught into Q naught, then P1 into Q naught, then P naught into Q1 and then P1 into Q1. Now P naught into Q naught, we have to multiply the entries in these two columns. So 4 into 10 equal to 40. Then we have 6 into 15 equal to 90. Then we have 8 into 5 equal to 40. So P naught into Q naught means 4 into 10, 40, 6 into 15, 90, then 8 into 5, 40. And let us write summation P naught Q naught also. Summation P naught Q naught will be the sum of all these, that is 40 plus 90 plus 40. So it is equal to 170. Now let us find P1 Q naught, that is the product of entries in these two columns. P1 is the price in the current year and Q naught is the quantity in the base year. P1 Q naught will be 6 into 10, then 4 into 15, then 10 into 5. So 6 into 10 is 60, then 4 into 15 is 60, then 10 into 5 is 50. Now summation P1 Q naught, it is equal to 60 plus 60 plus 50, it is equal to 170. Now we have P naught Q1. So it is the product of entries in these two columns, P naught Q1. So it is 4 into 15, then 6 into 20, then 8 into 24. So we have 4 into 15, 60, then 6 into 20, 120, then 8 into 4, which is 32. So summation P0 Q1, this is equal to sum of these three, 60 plus 120 plus 32. So it is equal to 212. Then we have P1 Q1. So we need to find the product of entries in these two columns. So it is 6 into 15, then 4 into 20 and 10 into 4. So here we have 6 into 15, which is 90, then 4 into 20, 80, then 10 into 4, which is 40. Now summation P1 Q1, it is equal to 40. 90 plus 80 plus 40. So it is equal to 210. So we have calculated all these. If we draw a table like this, it will be easy to do all these calculations. Now we need to check whether Paasche's formula satisfies time reversal test. So for that we need to find P01 into P10. Now P01 is the usual formula that we use. That is, it is the index for the current year using 0 as the base year. So it is equal to summation P1 Q1 upon summation P0 Q1 into, here we have P10. Now this is the index for the base year using current year as the base year. So it will be summation P0 Q0 upon summation P1 Q0. So this is equal to, here we have summation P1 Q1. So it is equal to 210 upon summation P0 Q1, we have it here, it is 212 into summation P0 Q0, we have it here, 170. 170 upon summation P1 Q0, we have it here, it is again 170. Here we can see that 210 upon 212 into 1, this is not equal to 1. This is not equal to 1. Therefore, Paasche's formula does not satisfy time reversal test. Does not satisfy the test. It is time reversal test. It is what is being asked. Now we will come to Fisher's formula. Now Fisher's formula, for Fisher's formula also let us find P01 into P10. Now for Fisher's formula, if we want to find P01 into P10, it is given by root of summation P1 Q0 upon summation P0 Q0 into summation P1 Q1 upon summation P0 Q1. This is P01 into P10, it is into root of summation P0 Q1 upon summation P1 Q1 into summation P0 then Q0 upon summation P1 Q0. So this is Laspeyres index, this is Paasche's index for P01, and this is Laspeyres index, and this is Paasche's index for P10. So here if we see P10, the Paasche's formula, summation P0 Q0 by summation P1 Q0. That is what is written here. Now let us substitute the values. We have all the values here. So this is equal to Since root a into root b is root of ab, let us have one single root and let us substitute each of these values. Now summation p1 q naught is 170, summation p naught q naught is also 170. So it is 170 upon 170 into summation p1 q naught is 210, summation p naught q1 is 212. So this is 210 upon 212 into, then summation p naught q1 is 212 and summation p1 q1 is 210. So it is into 212 upon 210, then into summation p naught q naught is 170, summation p1 q naught is also 170. So it is 170 upon 170. So these two will cancel out. Then 210 will go, 212 will go. So this is equal to root 1, which is equal to 1. So P01 into P10 is equal to 1. So we can see that Fisher's formula satisfies time reversal test. So we were asked based on the given data, we have to check whether Paasche's formula and Fisher's formula will satisfy time reversal test. So we drew a table like this and we took P0, P1. P0 is the price in the base year, P1 is the price in the current year. So they are given here. Then Q0 is the quantity in the base year and Q1 is the quantity in the current year. They are also given here. So based on these values, we found P0 Q0, P1 Q0, P0 Q1, P1 Q1. And we found summation P0 Q0 as 170. Summation P1 Q0 is also 170. Summation P0 Q1 is 212 and summation P1 Q1 is 210. To check whether Paasche's formula satisfies time reversal test, we need to find P01 into P10 given by this expression, that is summation P1 Q1 upon summation P0 Q1. This is the usual Paasche's formula which calculates the index for the current year using 0 as the base year. And now we have P10. This formula, it calculates the index for the base year using current year as the base year. So that is given by summation P0 Q0 upon summation P1 Q0. So based on the values that we have obtained, if we substitute the values, we can see that this is not equal to 1, which means Paasche's formula does not satisfy time reversal test. Now coming to Fisher's formula, given by P01 into P10 is equal to root of this expression into root of this expression. When we substitute each of the values here and when we simplify, we get it is equal to root 1 or it is equal to 1, which means Fisher's formula satisfies time reversal test. So with this, the syllabus for the term 1 examination for class 12 applied mathematics is completed. I hope this video was useful for you. Thank you for watching.